Hi there, my name is James Lindsay and I'm the Guru Regional Sales Manager, today talking to you about the Certimus and the rise of low power, user configurable digital broadband seismometers. Firstly, I'd like to speak about what Guru perceives to be the current needs of the seismic community and describe how this has led our design process for the Certimus. Over recent years, the seismic community has been calling for seismic monitoring solutions that follow four key principles, with the aim of making deployment simpler and more efficient. These key principles include higher tilt tolerance. This is especially relevant for deployments in dynamic environments such as glaciers and areas prone to landslides or subsidence. Lower power. Many temporary solutions across the globe rely on solar panels to operate in remote regions. Currently, IRIS recommends systems to have a power consumption of 2 watts, but they aim to reduce this recommendation by half to just 1 watt in the future. Small form factor. Remote deployments are not always accessible by car, and often equipment needs to be transported by foot. In addition, temporary installations are typically directly buried to improve noise performance, so naturally a smaller sensor requires a smaller hole to be dug for deployment. This is driving the demand for sensors to have an overall smaller footprint and weight to make this easier. User configurable. Users of seismic monitoring equipment are increasingly demanding that equipment be suited for a wider range of monitoring scenarios. This began with user-selectable gains or force balance accelerometers, but is now progressing to other parameters in broadband velocimeters. Following on from these four key principles, Guru have developed the Certimus with the aim of being the next generation seismic monitoring station. Guru has extensive experience working with the seismic community, being founded in 1985. Since then, this has given us lots of opportunity to listen to customer feedback about the future of product development, and we'll be able to suit products to the needs of the seismic community. This began with an engineering strategy change in 2015 that saw the introduction of new products such as the Affinity and the Fortis accelerometer. In 2016, the Radian was released, which was the world's first truly omnidirectional broadband seismometer, suited for post-hole and borehole applications. We then took this sensor technology further, enhancing and reducing the power consumption to develop the Aquarius OBS system, released at AGU 2019. This features the same omnidirectional sensor system as the Radian, without the use of traditional gimbals. This now relatively mature sensor technology has been repackaged by Guru into a surface sensor designed for efficient and quick direct burial applications. We have called this sensor the Certimus. Here we can take a closer look. Performance-wise, the sensor has a flat frequency response of 120 seconds to 100 Hz. This is in line with Guru's renowned 3T sensor. However, because the digital sensor components inside the Certimus have the capability for the frequency response to be configured by the user, this allows you to adjust the sensor's long period corner from 1 second to 120 seconds, according to your requirements. The Certimus has the same omnidirectional functionality as the previous Radian and Aquarius systems. This means that deployments in dynamic environments are no longer a challenge. Taking other elements from the Aquarius OBS, the Certimus can be configured by the user to drastically reduce the power consumption down to less than 300 milliwatts. This significantly eases the logistical challenge of organizing a reliable power source. All of these next generation features are controlled and configured via the integrated Minimus digitizer, which has proven to be extremely popular since its introduction to the market in 2017. Guru has worked extremely hard to ensure that there is little to no compromise to performance in return for the revolutionary features that we have discussed previously. At the lower frequencies, the sensor provides especially low noise characteristics, proving better than other compact broadband seismometers on the market. The ability of the Certimus to work up to 45 degrees will prove particularly important in this environment, as the instrument will continue to record valuable data, even if the ground becomes saturated with water, for example, and the orientation of the instrument begins to change during the deployment. The low power consumption means that the required power supply infrastructure is reduced, reducing the need for solar panels and batteries. This makes trips into the field to deploy the system far easier. As you can see, a suitable hole can be dug in a matter of minutes for the Certimus due to the small form factor. This requires just basic tools to be able to install the sensor relatively quickly and easily. Here we can see the Certimus being configured prior to deployment with the AGU application that can be downloaded onto Apple and Android devices. This is easy to check and ensures that the system is good to go for deployment. Certimus, making deployments more efficient. We know that there are more to deployments than just installing the equipment in the field. Transportation, power and data gathering are all important additional factors that need to be considered. This is why Gurab have designed and developed a range of accessories to facilitate more efficient deployments. These include the deployment backpack, the portable power module and the surface storage module. We will now look into these in more detail and see their benefits. The deployment backpack contains everything required for your standard deployment, including the sensor and GPS cable. As you can see, the backpack is ruggedized to survive the harshest of environments and ensure that vital equipment remains safe. The compact form of the backpack ensures that the system can be carried by a single individual, improving the efficiency of installation trips. The custom foam inserts provide excellent protection for the Certimus from your typical knocks and drops that may occur during deployment. Here we can see how the equipment can be easily removed from the deployment backpack once the installation site has been reached. The PPM is compact enough to be transported easily with the Certimus. The system has enough capacity to run the Certimus for up to 6 weeks when the unit is set into the ultra-low power mode. There is also an additional port on the PPM that allows for the unit to be charged with solar panels. The Surface Storage Module, or SSM, is the ideal optional accessory to allow for locally stored data to be retrieved without disturbing the instrument during deployment. This is great for situations where the instrument will be directly buried in remote locations and the data is required to be collected during deployment without the disturbing of the instrument. The SSM is also available with Bluetooth connectivity, so that the AGU app can still be utilized when the instrument is buried. As you can see, it attaches in line with the GPS. The Certimus has already been extensively field tested in Iceland with the University of Cambridge. Here we will look at the setup of the instruments and some of the data that they provided. Firstly, I'd like to say thank you to Nick Rawlinson, Connor Bacon and Tim Greenfield from Cambridge, who collected the data and have allowed us to present their findings. These are earthquakes from Iceland's national catalogue between June and August of this year and are shown by the black circles on the left-hand figure. The Reykjanes Peninsula has been very active this year, with a series of magmatic intrusions near the town of Grindavik, causing uplift at much higher than usual levels of seismicity. Whilst research is currently ongoing, the large swarm stretching southwest to northeast is a large strike-slip fault probably activated due to the uplift. A series of magnitude 4 earthquakes and above along this fault have occurred in August. Since August, activity has shifted eastwards with the triggering of more magnitude 4.5 earthquakes and higher. The high levels of activity along the Reykjanes Peninsula this year could be a precursor to a significant magmatic episode along this section of the rift. However, previous high activity levels, at least 2 within the 20th century, have fizzled out with no eruption. We can see some of the data from the Iceland study on the left and comparisons between the 6TD and Certimus instruments. Overall, the data quality of the Certimus was excellent and has allowed for the detailed study of the region. Thank you very much for listening to our presentation on the next generation of seismic stations, Certimus. If you would like to contact me directly with questions or queries about the Certimus, then you can contact me using the details on screen now. For now then, enjoy the rest of the AGU week. Goodbye.